Yo, all right, time to kick it up. We're solving differential equations. Now we're going to solve what we call initial value problems. All right, nothing to get freaked out here. An initial value problem is basically, or actually it is, just a differential equation, but then you're also given some initial condition to figure out what that constant is. So it's just an added extra step. So there's nothing to get bananas about. All right, so here we go. So how do we solve differential equations? All right, you will only be responsible to solve separable differential equations. So the technique is, yes, you guessed it, separation of variables. So if you remember, right, you got to get your y's on one side, your x's on the other, and the dy dx term will always dictate that. So since dy is in the numerator over here, that means all the y's are going to come to it. So you have a y term over here, and it's connected with multiplication. So if you divide both sides by y squared, you're going to end up getting that, and everyone's happy. Okay, moving on. You see the dx is in the basement here. That's no good. We got to get it up top. The only way to do that would be to multiply both sides by dx. It would cancel over here, and you would end up getting this over here. Why was this good? Well, because now I have both sides in a Riemann integrable form. The dy's and the dx's are connected with multiplication, right? So I can write this side as 1 over y squared, or maybe better yet, y to the negative 2 dy, and then over here, negative 4x dx. Just leave that alone. Again, you can see they're both connected with multiplication. All right, so I need to integrate this now. So I'm going to integrate the left side. I'm going to integrate the right side. When I go to integrate the left side, I'm just going to do the power rule. Power rule says add 1 to the power, so negative 2 plus 1 is negative 1. Then divide by that new power, right? So it'll be like 1 over negative 1, okay? And then you're going to get equals over here. You're going to get negative 4 times a half x squared. And now you have to add that constant of integration. Technically, I guess I should be adding it to both the left and the right. But you saw in a previous video that at the end of the day, you're just going to subtract 1 over to the side you want. So you just have to add it really to one side. And since we want to solve for y here, right? You know, how do you know that? Well, because it says y equals f of x. We'll add the constant just to that side. All right, we're good to go. If you don't do that on the AP test, they hammer you. So say there's a 9-point question and you forget the constant, you're going to lose a majority of the points. So you got to remember that constant. All right, the other thing here too, I kind of did this seamlessly. You may have initially had this as 1 over y squared dy, and a common error would be to think that the antiderivative is ln of, but it's not, right? It's only when it's 1 over y would it be ln. So you don't have a choice here. You have to use the power rule. All right, so I really kind of have a choice here, and this is totally up to you. I can solve for the constant now by plugging this point in. So this is my x value, this is my y value. So I can do that now and solve for the constant. There's nothing wrong with that. Totally could do that. The other option is to hold off and solve for y and then solve for the constant. You can really do either or. It's kind of preference, and even sometimes depends on the function, how it plays out. I'm going to hold off on solving for the constant. I'm going to solve for y first. So the first thing I might do to spruce all this up is right here, maybe simplify that. 2 goes into that twice. Well, howdy doody time, or happy about that. Multiply both sides by negative 1, and I'm going to get y to the negative 1, which maybe now I'll write as 1 over y equals negative 2x squared. And I said I multiply both sides by negative 1, so that's really going to be plus 2x squared and then minus c. If I wanted to be fancy, I could write plus k, just because it'd be a different constant, but minus c is fine. And you get here, and so now the calculus world is over. This is pre-calc. You're like, well, how do I solve this? You can actually just flip both sides, but you have to flip the entire side, right? So I'll flip this side, I get y, and then flip this entire side. So I get 1 over 2x squared minus c. And there's my explicit general solution. So this is your explicit general solution. Okay, and if that's all they wanted you to be done, but they actually want you to get the particular solution. So to do that, I have to use this point. So we're going to use now y of 0 equals 1, which remember, that's just a point, 0, comma 1. Here's my x, here's my y. So 1 goes in for y, 1 over 2 times 0 goes in for x. So now I'm going to get 1 equals 1 over negative c equals 1. c equals -1. Now that I have my constant, I can put it all together, and I can say that y equals 1 over 2x squared, and then it would be minus c. So minus -1, so that's going to be y equals 1 over 2x squared plus 1. Put a happy cloud around it, all right? That is your explicit. You know why it's explicit? It's explicit because we were able to explicitly solve for y. But now we call this a particular solution. And that's because we actually were able to solve for the constant. All right. And there is your first initial value problem, which not too bad. All right. Any questions? I didn't think so. All right, here we go. Let's go to the next question. So rocking and rolling. It says find the particular solution. So here we go again. X equals Fy to the initial value problem. All that means is you have a differential equation like that guy right there, and then an initial condition. All right, so it should be easy, but maybe you notice this little sticky wicket, right? So what do you think the deal there is, right? And they don't really do this a lot, but I decided to throw it at you. This basically means now when you go and get your solution, rather than solving for y, you're going to solve for, yes, x, all right? So you're going to get x by itself. So all right, we'll just deal with that when we get to it. So let's go to our differential equation. So what am I going to do here? So I have like things with subtraction, addition. That's no bueno, right? You really want products when you're separating variables. So the first move that I probably would do is I would take that 3x squared and add it to both sides. So I end up getting that. And now this is actually going to be pretty easy breezy. All right, the y's have to go on the left side. How do I know that? Because the dy is upstairs over there. The x is going to have to go to the right side because I got to get this out of the basement. So if I just multiply both sides by dx, I'm going to be rocking and rolling. So if I do that over here, I end up getting this. Right? And so now you have the variable separated, y is on the left, x is on the right. They are in Riemann integrable forms. In other words, the dy and the dx is connected with multiplication. That's huge. That has to happen. So once you have that, it's the green light to go ahead and integrate both the left and the right side. The left side is a difference. Integral the difference of the integral. So the integral of 4y would be 4 times a half y squared minus the integral of cosine y. Do you know a function whose derivative is cosine y? You do. It's sine y. All right. And then I'll leave a little space here, equals, and then let me integrate this guy. So 3 times a third x cubed. So previous problems we've been adding the constant to the right side. That's where the x was. And it's not that I can't do that, but since I'm looking to solve for x, you know what? I'm going to add the constant to the left side this time, all right, away from here. And I called it K instead of C because I can, all right? So let's spruce up, right? 2 is going to go into that twice, and this is just completely going to get wiped out. And so if I rewrite what I have now, I have 2y squared minus sine y plus K equals x cubed. Okay, so what is this actually? Because this isn't y solved for and it's not x solved for. So, but it is called something. This is called your implicit general solution. So this would be your implicit general solution. If you hear that in the background, that's my boxer mutilating my chihuahua. All right, so here we go. So now what's the story? We didn't want the implicit. By the way, why is it implicit? Well, because y and x are not solved for. All right. So now what can I do here? Just like before, I have options, right? I can use this point, right, which is basically just 0, 0, to solve for the constant now immediately, or I can wait until I solve for x. Since I'll be different than the last time, I'll use it now. So what does this mean? Well, this is basically the point 0, 0. So 0 goes in for x and 0 goes in for y. So that's easy breezy. So if I do that, 2 times 0 squared minus the sine of 0 plus k equals 0 cubed, right? This is bananas how this is going to work out. So that wiped out. Sine of 0 is 0. That's 0. So we kind of get lucky here. K ends up being 0. So now if I go back, I'm going to go 2y squared minus sine y plus 0, which I'm not going to write that, equals x cubed. And this has a name too, right? So it's still implicit, right? So all right, I'll give you 30 seconds, which means you have to hit pause to tell me why this is implicit. Go. All right, welcome back. You are correct. It is implicit because neither x nor y is solved for. But now it's a particular solution, not a general solution. Why is it a particular solution? Because we solved for k. K was 0 here, right? So once you do that, it goes from general to particular. So kind of semantics with the names, but you should know them. And so, to solve for x here, it should be pretty obvious what to do, right? If you want to get x by itself, you either cube root both sides, or you can raise both sides to the 1/3 power, which I like better. So I'm going to go 2y squared minus sine y, all of that quantity raised to the 1/3 equals x. And now this would be your explicit particular, I can't write over here on this side of the board, solution. All right. And that's your answer. All right. So really not too crazily bad. So I gave you two solid examples there. I don't want to go too long with this. So I'm going to get straight to your homework. So I'm only going to give you 2 homework questions tonight. All right. Basically solve each initial value problem. So you have a differential equation and initial condition, right? This for y greater than 2. You can almost kind of ignore that for now. I'll talk about that more later. Here's another problem, question 2, where here's the differential equation. Here's the initial condition. Don't get freaked out because sometimes I do y of something equals something as opposed to f of something equals something. It's the same deal, right? We're solving for y equals f of x. But this question has a little bit of what's the word? See if you can figure it out question, part B. So once you actually get your particular solution, y equals f of x, I want you to figure out what the domain is. And you're going to have to go back to your pre-calculus and algebra 2 days to do that. But then you're also going to have to add this note to that. So in other words, you should know how to find the domain of a function. So once you do that, though, read this little message. It says the domain of a particular solution to a differential equation is the largest open interval containing the initial value in which the solution satisfies the differential equation. Even when I read that like that, that makes no sense to me. So my hint to you is going to be once you get your function, graph it in your calculator and see what's going on and see where you can find an open interval and what you'd have to state it to be. If you get it and you remind text me or email me, I will give you nothing. I'm kidding. I'll give you like a smiley face emoji back. And actually, do me a favor and try and remind text me. And if you can't, then shoot me an email on my school email because that I do know works. Just so I know if I need to have if you want to ask a question, you can ask me a question through Remind. If you can, I might have to open something up. So do me a favor and do that if you could. All right. Hope all is well. Peace out, Cub Scouts.